Surveyor Program. This was NASA's robotic precursor to Apollo, designed to prove a soft landing was possible and that the lunar surface was firm enough for a crewed lander. The Surveyor probes were elegant, spindly spacecraft that used Doppler radar and throttled engines to achieve a pinpoint landing. Surveyor 1 landed flawlessly just 4 months after Luna 9 and was followed by 4 more successful missions. These landers took thousands of images, tested the soil, and provided the final engineering confidence needed to send the Apollo astronauts. LM. Arguably the most famous spacecraft ever built, the lunar module was the first and only crewed vehicle designed to land on another world. A masterpiece of engineering, the LM was a 2-stage, purely functional machine that could only operate in the vacuum of space. It consisted of a descent stage with the landing gear and powerful engine, which served as the launch pad, and an ascent stage, which was the tiny cockpit that would carry 2 astronauts back to orbit. From 1969 to 1972, 6 Apollo LMs successfully landed on the Moon, a monumental achievement in human history. Lunar Program. After losing the human race, the Soviets perfected a new kind of lander, a robotic sample return vehicle. These sophisticated landers were designed to do the job of an entire Apollo mission automatically. Luna 16, 20, and 24 all successfully landed on the Moon, used a robotic drill to collect a core sample of lunar soil, placed it in a small return capsule, and then launched that capsule off the lander's platform back to Earth. The program also included Luna 23, which successfully soft-landed in 1974, but was damaged during landing, preventing a sample return. They were the first, and for decades, only successful robotic sample return missions from the Moon. Lunokhod Program. This was one of the Soviet Union's most spectacular lunar lander types, designed to deliver the Lunokhod rovers. The landers for the Luna 17 and Luna 21 missions were designed not just to land, but to deploy a payload, the Lunokhod rovers. After a successful touchdown, these landers would extend a pair of ramps, allowing the large 8-wheeled rovers to drive down onto the lunar surface. The landers then served as communications relays for the rovers, which went on to explore for months and travel for kilometers across the Moon. Chang'e 3 and 4. After a nearly 40-year gap in lunar landings, China restarted the era with this new generation of landers. Chang'e 3, which landed in 2013, was the first soft landing since 1976 and deployed the small U-2 rover. It was followed by the historic Chang'e 4 mission, which in 2019 achieved the first ever soft landing on the far side of the Moon. These missions established China as a major lunar power and were crucial steps toward their more ambitious goals. Chang'e 5 and 6. This is China's modern, highly complex robotic sample return lander. Building on the lessons of the Soviet Luna missions, the Chang'e 5 lander was a multi-part vehicle designed for a fully automated sample collection and return. It successfully landed in 2020, used both a scoop and a drill to collect a substantial sample, and then launched a small ascent vehicle back to a lunar orbiter to transfer the sample for its return to Earth. The closely related Chang'e 6, originally built as a backup to Chang'e 5, and later adapted for a farside mission, successfully repeated this feat from the lunar far side in 2024. Vikram, India's historic lunar lander. After the heartbreaking crash of its predecessor, the Chandrayaan-3 mission successfully landed its Vikram lander near the Moon's south pole in August 2023. This achievement made India only the 4th country in history to successfully soft land on the Moon. The lander deployed the small Pragyan rover and conducted a series of scientific experiments on the surface, marking a triumphant success for the Indian space program. SLIM, Japan's Moon Sniper. SLIM was a small, experimental lander with one primary goal: to demonstrate a pinpoint, high-precision landing. Using a novel vision-based navigation system, it successfully touched down in January 2024 with an accuracy of just 55 meters, a stunning achievement compared to the kilometer-sized landing zones of previous missions. Though it landed upside down due to an engine issue, it proved a crucial technology for future missions that need to land next to specific geological features. CLPS. This represents a revolutionary new era in lunar exploration, led by private companies under NASA's Commercial Lunar Payload Services initiative. Instead of building its own landers, NASA pays these companies to deliver science payloads to the surface. The first to achieve a soft landing was Intuitive Machines' IM-1 Odysseus lander in February 2024, becoming the first private vehicle to land on the Moon. It was followed by additional CLPS landers, including Firefly Aerospace's Blue Ghost Mission 1, which landed successfully in March 2025, and Intuitive Machines' IM-2 Athena, which reached the surface in March 2025, but came to rest on its side, limiting operations. These commercial landers are now set to become the primary method for robotic delivery to the lunar surface in support of the Artemis program. HLS. The successor to the Apollo lunar module, the HLS is the next generation of crewed lunar landers. It is not being built by NASA, but by commercial partners. The first vehicle selected is the Starship HLS, a specialized version of SpaceX's massive Starship spacecraft. It will be used on the Artemis 3 mission to carry 2 astronauts from lunar orbit down to the surface, where it will serve as their habitat and base of operations before ascending back to orbit. Unlike the Apollo LM, the Starship HLS is designed to be fully reusable. Thanks for watching. Which lunar lander do you think was the most impressive, and why? Let me know what you think in the comments. Also, please remember to like and subscribe if you enjoyed this video.